Hello, ERA users. Today I wanted to showcase some of the new features that are coming out in ERA version 4.15. Starting with this version, we now have the ability to import and manipulate time-based data and port that data into the depth-based mode, which is where we normally view our theoretical plots and our observed values, both while off-bottom and while on-bottom drilling. So in order to use time-based data, we have to start with an executed well design. And you can see on my project desktop here, I have an executed well design. If you haven't done that before, you just simply right-click on an unexecuted well design and it'll provide an option to where you execute. And that will create a well design sketch that looks like this one in green. And I've already pre-populated this with well trajectory and other data. And you can see that I have two executed subops, 8.5 inch run one, or sorry, 8 3/4 inch hole run one, 8 3/4 hole run two. Both of those, the only data in there right now is just measured mud properties. And I'm going to try to populate all of the off bottom and on bottom drilling data using just time that I've extracted from TOTCO. Over on the left, you can see there's a tab called time data. If you click on that, it will pull up the repository for your time-based data. There's two screens here, and they can be navigated in the upper left-hand corner, what we call segregation and rig state filters. And they look very similar, but one's just the beginning of the workflow where what we're trying to do is determine which subops are occurring at different points in time once we upload our data. And that will make sense here in just a minute. So to upload data, we come over here to the upper right-hand corner, the data button. And in the upper right hand corner of that screen, you can see there's a button called import. Pulling up the import screen will bring you to your desktop. And if that's where your data happens to be located, I've got a CSV file located here called time data. You can also import LAS files, but in this case I have a CSV or comma separated value file. And I'll click open and ERA will attempt to import this data. It'll give me a list of all the channels that it detects, and then it's up to me to decide which channels I want to import. In this case, I'm going to bring them all in. So I'll just go down the list here, picking each one of them, moving it on over. What the system has to do is attempt to read the header in your file and figure out what each one of those data channels means in the ERA world. And sometimes it's able to figure it out. Most of the time it's able to figure it out. Sometimes it doesn't. And I'll show you some examples of what that looks like. So you can see that on the left, this is the column header within the data file itself, and this is what ERA interprets that to mean in the quote-unquote ERA world. So hole depth, it understands. What it doesn't understand here is diff press, and the header here is diff press. ERA doesn't know what that means, so I'm going to pull up the drop-down menu here and find differential pressure right there. And now ERA understands what that means and it'll use it in the hydraulic calculations. Just want to kind of do a quick QC here and make sure that all the channels are assigned. Slip status, it's another one it didn't interpret correctly, so I'm going to scroll on down here and find in slips. That's what that one means. And once that's identified, I can click OK, and it'll bring the data in. Once it's done porting in the data, my table will be populated. I can close that, and you can see it's graphically displayed now on the segregation screen. What I need to do now is identify subops, and I can do that by hitting the plus button and then tell it, okay, what exactly are we going to call this thing? Well, drilling is the very first part of my data. If you look at the depth and the ROP, you can see I'm drilling from 2,000 feet down to about 10,000 feet. And what I need to do is determine the start and end time. And I can do that by graphically grabbing this vertical line and moving it to the end of that first run and then sending it to the correct subop. Now run one, I've already executed in my well summary. And the next subop in the list here is tripping out. You can see I drill down to 10,000 feet, the string's tripped out, trip back in with run number two, and then I drill run number two. So that's essentially what we're doing here is just assigning what the different sub-operations are for each run and telling the program when the start and end points are. And if you do this in chronological order, it's pretty easy. You can just grab the bars and delineate the beginning and end, and it doesn't matter if you're a little bit off. It's not the end of the world. You'll still accomplish the main goal, which is to port this data into the depth-based domain. All right, last sub-op, drilling. Come over here on number 2. All right, so I should have all of my time data allocated to the correct sub-ops, and you can see that the data is colored. What each one of those colors represents is different, what we call bins. And if I double click here on the vertical or y-axis, you can see the bins are categories of what the rig is doing, or rig states: picking up, slacking off, rotating off bottom, slide drilling, rotary drilling. Those are all different conditions that the rig could be under, and that's important because that's how we move the data into the correct places within our calculations. You can also see on this screen, remember I access this just by double clicking on the y-axis. It will pull up all the different channels that I can display, and you can just check all the channels that you want to show if you're interested in looking at more. From this screen, you can also turn on and off auto scales. By default, auto scale will be on. If you want to shut off the auto scale and set your own scales, you're free to do that here. You can also change units. The other thing you can do from this screen is change the orientation of the time axis. By default, time is on the x-axis, but you can click this radio button and change it to the y-axis. And you can also select whether or not you want to color channels rather than color bins. So remember, bins are the rig states, and channels are the streams of data. So maybe for presentation purposes, I only want to have specific channels colored different colors. You can also turn off the shading that's in the background, and also the vertical bars that delineate the beginning and end points of the different sub-ops. So that all can be done from this screen. If you want to view the data a little bit closer up, this little arrow button will expand, and you can also zoom in by holding down on the control key on your keyboard and then using your mouse scroll wheel to zoom in closer. If you don't have a scroll wheel, or that's inconvenient, say maybe using a mouse pad, you can also do it via this bar on the bottom. You can expand your time scale. You can move the time scale left or right, forward or backward, and then you can also double click on it to return to the full time scale. Once I've segregated each of my sub-ops, then I can move on over here to rig state filters. And ideally, you won't have to mess with rig state filters all that much. This is preloaded with different routines, what we call binning rules. And that binning rule is just a sequential set of conditions, true-false statements, for lack of a better word, that separate the data into different categories. So where all the data starts when it moves in is what we call the undefined bin. It hasn't been put in its proper place yet. So at the very beginning of this routine, data starts in the undefined category. We're going to move it into the rotary drilling category, and I'm going to do that by targeting and focusing on the ROP channel. If ROP is greater than 1 foot per hour, the system is going to recognize that as rotary drilling. The next step in the process here, we're going to move out of the rotary drilling channel and into the slide drilling channel if my surface RPM is less than 40. Now, 0 would be the obvious number that you would use if you weren't rotating, i.e. slide drilling. However, with a rocking system, which a lot of rigs are using now, especially in long horizontals, the top drive will log a certain rotary speed even when you're quote-unquote slide drilling, and we want to assign that in the correct category, and so you have to set some value greater than 0, and in this case it worked out to about 40 RPM. You may need to alter that up or down in your particular case. I won't go through all the steps here, but it's just a logical sequence for cleaning up the data and providing a kind of reasonable, sensible output. And I'll show you where that's located. We'll close this screen. If we navigate on over to one of our sub-ops, you'll see in the data page, that's what it brings you to, you've now got a time tab in addition to your depth and your output tab. The time tab is not editable. That's all being ported and moved directly from your time-based data. The depth tab you can still add manually measured data to, and in the output table it's going to merge both time and depth unless you turn off your time-based data. And you may choose to do that. Maybe you're not getting a good filter on your time data and you just want to override that and use your manual depth-based data. You can do that here. Down on the on-bottom data, you can see we also have a time and a depth tab. and then an output is just the merging of those two different domains. For example, maybe you only have flow line temperature or MWD temperature measured in the depth domain. Well, you can enter that in here and it will get merged with your time-based data to provide an output that's synchronized. If all this is done correctly, when I come on over here to my on bottom or off bottom plots, you can see that the time-based domain has now made its way into my depth-based data. I didn't have to manually input any of this, but I've got an overlay of actual values on top of my theoretical curves, and you can do all that, do whatever you're trying to do with this data at that point. So it's a big time saver. It is a very convenient way to get data into ERA. And in the future, we'll be establishing a streaming link using WITS or WITS-ML to move the data from whatever your data logging source might be, Payson, Totco, maybe your directional provider, and move that into ERA live in real time. So that's what we'll be working on in 2018. But for now, hope you enjoy this tool. If you have any questions or problems with the ERA, email us at kmtsupport@kmtechnology.com, or my email address is bfoster2@kmtechnology.com.